Well, sometimes things don't go as planned. And I run into a little hitch on this right case, and I have to do something a little different to make it work. And I'll show you that in a minute. I thought you might find this interesting. You know, I've had this K model for probably 3 decades, and I ended up with it because no one else wanted it. No one else wanted to deal with K models or old Sportsters because the failure rate is high. And especially if there's been any welding on the cases. That's a disaster in itself. But when you end up with mismatched Sportster cases, that's real bad. And I poked around on eBay looking at old K-model cases and 900cc Sportster cases, and just about every set is busted and welded. And so you're going to have to, if you're going to deal with something like that, and I've dealt with them, is you're going to have to use the factory lapping tool. I don't know how to build an engine properly without that factory lapping tool, but I have everything in this machine shop here to create that tool. And not everybody's so lucky as me or has all the experience that I have. Before I got involved with Harley Davidson, I mentioned I was working on the nuclear projects that never produced a single working reactor. And it was an absolute colossal waste of money. They sold bonds and all this stuff. This is in the 70s, in the later 70s when this fiasco went. But I tell you what, I got in the right spot then and got into that and learned to use the Monarch 10 double E lathe exposed to the tool and cutter grinder, and I want to try to find alternatives because not everybody's got a 2,000-pound tool and cutter grinder or a Monarch 10 double E lathe like I got over there that is better than the one they want $40,000 for on eBay. I didn't buy that thing just for Harley Davidson, since I was doing hydraulics and stuff too. And you know, one of the funny things about the Monarch 10 double E lathe, I kind of hold back a little bit because I'm waiting for a tool and die maker to show me how to use it. And guess what? I don't think tool and die makers ever used a Monarch 10 double E, but we certainly used them over there making nuclear reactors, or attempted to anyway. The reason for that is because there's a lot of high nickel alloys. There's Hastelloy. There's all those crazy alloys like that were used over there. High nickel content stuff's really hard to cut, and it work hardens. And you never, you'll see me cut threads and stuff, but I never do what's called a spring pass. Never. Always make a chip. That's how I make those threads bang on accurate. I've shown a little bit of that. I'll show a little bit more. But right now we're focusing on hardly old Abelsons are made at 10. You write them out, then you have to push them back in. I got that. There's an old Indian dealer here named Nobby. And he was the dealer, I think in '53 they quit making them. And then they branded some British bikes and he sold those. And what did he do after that? I think he got, Yeah, he sold a few brands of the British bikes. There was just across the state line here, there was a Triumph dealer. So Nobby, he got those other ones. A popular one was the Greaves, which had a 250cc two-stroke engine in it, and they were kind of real popular because they were good in the hills and stuff, and they made some trials bikes. That was kind of a big thing years ago here, Scottish trials with those old things. They're kind of fun to watch. But anyway, I was looking at this K model carburetor, and I don't know if you can see in there, but this is a performance carburetor. I'm going to get back behind the camera and see if we can see what I see. Looking through the back of that carburetor, now inside there is a Venturi, and it's they call it a bomb sight. See if I can get it against that wall, and you can see that bomb sight Venturi in there. This is a performance carburetor. It's kind of cool. I never looked in it. I had no idea that they did that bomb sight carburetor. I think you can see that Venturi back in there. Well, anyway, let me sit back down. I'm kind of tired. Been a long day. So I'm going to talk about some interesting things I find interesting about it, about this kind of work, is if you're going to work on the worst of the worst, you need the machinist skills, you really do. And if you're not very polished up on it, I suggest watching Blondie hacks and get the basics, and that's, everything I'm doing is just setup. But I can spend a couple, 3 hours setting something up to make a 5-minute cut. And it's not any more complicated than what Blondie hacks. It's a channel for new machinists, and she goes through some pretty cool stuff. And one of the best things that she does, and it's the same thing the Navy machinist instructor did here years ago at our community college, is steam engine models. That's just a fantastic project. So, I had all that stuff under my belt, working on hydraulics and gearboxes and stuff like that from the machinist standpoint after I gained those skills, which is real valuable. So when I went to the Harley factory school, I was a pretty sharp machinist, knew my way around the shop, done just about everything. And I knew the problems of the engines and stuff like that from owning them. And one of the things that was kind of bad here, I don't know, around and stuff, was the cost of rebuilding an engine in like the mid-1970s. And around here, the average cost of rebuilding an engine was $1,200, and that's a lot of money. And there's people out there that offer engines to this day for $1,200, but you're not going to get a good engine. And there's one guy, I'm not going to say his name, he's been known to put out crappy engines for decades, but people send stuff there, and I guess in that state where this guy is, he must be protected from lawsuits, because here in Washington, Santa Claus don't come here because he gets his pantsuit off. This is a sue your ass off state here. It's just terrible. So let me set that carburetor down. But with basic machine skills, you can see some bad practices. And one of them I seen, and I've seen it in a couple places. I've seen it on someone doing dirt bikes, and I've seen it with that idiot that does those cheap engines, is grab a cylinder by its thin sleeve and bore it in a lathe. It's totally ridiculous. That's just terrible. Because, grabbing a 3-jaw chuck and bore it by that sleeve sticking out the bottom, that's absolutely crazy. And it's just bad practice. You need to come up with a better fixture. And what I did was I come up with a fixture I hooked to a faceplate, and I've showed some of the one fixture I have on a faceplate. But I made one to hold cylinders, and what it does is I can hold them different ways, and I think I have a picture of a cylinder spinning in that blue Lodge and Shipley lathe that was in this building. And I'll put that picture up on this video of me 3 decades ago or more in this building here, and the walls weren't quite finished. And there's a giant Lodge and Shipley power turn with a Copymatic attachment on it that I rebuilt in here, or at least got going. And I had a Bridgeport sitting in here too at that point. But anyway, I'm going to get back to some interesting things you might find interesting. One of the things, I was on a forum years ago, as a matter of fact, that stinking Practical Machinist forum, in this complete jerk face that had a company that sold clutches and performance clutches, and I think the clutches are all right, but the owner's just a piece of crap. He's probably dead now. But I totally freaked that guy out by stating this. Those connecting rods and crank pin complete assemblies you see on the internet or catalogs for $149 is garbage, absolute garbage. You'd be lucky if the engine makes 10,000 miles with that. And I'm going to point out this guy, this idiot guy. He does this bait and switch kind of thing. He goes, well, this is a build-it-yourself thing or something. You have a choice of a Eastern motorcycle parts crank pin, which is probably made in, I don't know where, who knows, China, or a Jim's crank pin. Well, a Jim's crank pin is really expensive. And I'm going to point out that a Jim's crank pin with their bearing cages and bearings for the rods costs more than a complete set of those import rods. And a funny thing about those import rods, they were actually put in some Harley Davidsons in 1979. In 1979, if you have a 1979 Shovelhead, take a look at the bottom where the centerless ground studs go. And you'll see nuts on both sides, 5/16 fine thread nuts, and the stud's quite large, and the threaded portion is 5/16. Well, there's centerless ground and their precision, and then they ream the cases there for those studs to go through. And for some reason in 1979, not all of them, but many of them, they quit doing that. And they quit doing that for 1 year. And what happened is they just stuck bolts through there trying to save money, just these 5/16 bolts, and they have a head on one side. That's how you tell. They have a bolt head on one side, then a nut on the other, then you got one of those engines. And so if they don't have the centerless ground studs, then it's depending on the motor mounts on the frame to keep the engine together. And the motor mounts might be off, the frame can twist and bend, but those engines will tend to leak oil more because of that. And that became a problem. And the solution I had for that is put dowel pins in it, just like I'm doing here, okay? But I had to locate them. It was too difficult to put the centerless ground studs in. You have to have reamers and stuff like that. And back then I didn't have a cutter grinder to do that kind of stuff. I can now. Grind the reamers and get the cases lined up and run reamers through. It's like 1979. And what that's what kind of got me into the factory school, because I bought a new Sportster in '77 when I was working on the nuclear project. I was getting paid real good. And I met the regional factory representative. His last name was Churchill. He's a pretty nice guy. And he kind of took a liking to me because I wasn't one of the hippie bikers all covered with tattoos like you see the group in the front. Not saying bad stuff about people or anything, but those are kind of not likely to succeed in the nuclear stuff anyway. But the shop owner, the guy I bought the bike from and eventually worked for, had a 1979 lowrider. And it was leaking oil and stuff like that, and he took it apart, and he goes, man, what did they do? What did they do? And they even put those import rods in it that year for some reason, either a full set or one of. And I'm going to tell you something you might not know. The greatest stress on a connecting rod is not the piston pushing down on it. The greatest stress occurs near the end of the exhaust stroke, when there's no cushion from compression and it stretches the bottom of the rod out. That's no kidding. And that was kind of a problem with the engines up into the Evo style. But I'll tell you, the very last Shovelheads had an Evo crankshaft and Evo 4140 forged rods in it instead of the malleable cast iron. They had a tougher crankshaft and tougher rods in the very last Shovelheads. And those were the best. And a lot of times the last of an engine series is the best. And I'll say like panheads, 63 to 65. And I've had each year of those. I've rode each year of those and owned them. The last one I had is a 65. I sold a while back to some dope addict asshole. And I came over here, I don't know, with a bunch of creeps and stuff. But anyway, I sold it to him, and glad to be out of it. I just really was done riding those things. But so I have experience with these things. And I learned a lot at the factory about these things. The best engines they probably built of those iron cylinder big twins was 63 to 65 panheads. And the Shovelhead was a colossal mistake. And one of the reasons is the intake valve's too big. And when it brings the gas in instead of a swirl that happened with the pan heads, because they had a real long manifold that went back to the cylinder straight like that, and these long ports, and you got this velocity and more of a laminar flow that caused the fuel to come in and swirl and mix better with the air. The shovel heads, with that bigger valve and that short standoff Y manifold, the fuel comes in like a cloud, and it's got not as mixed as good, and then it can pre-ignite and knock and things like that. And as a matter of fact, the shovel head, the 66 shovel head, look at the specs on it. They changed the RPM where it came up with horsepower, and it's just kind of, they made a mistake. We can't sell this new engine with less horsepower than a pan head, but in fact it did. So back then, the performance guys that did heads and stuff for shovel heads welded up the intake ports on the bottom, forcing the mixture up to the top. Then when it comes down into the cylinder, it affects a swirl, get that swirl effect. I thought you might find that a little bit interesting, because I did very much. So then a whole bunch of other colossal things happened to the shovel head. They changed the oil system from high flow to low flow, high pressure. About, I think the 66 still had, 66 to 8 still had the cast iron oil pump. Then 69, they put the aluminum oil pump on it, and those are pretty good engines. The 66 to 69. Then they got rid of the generator and went to the nose cone engine in 1970, and those engines had nothing but oil problems. Oil puking out, because the space in the cam chest was reduced, causing more problems back. If you go back to where I showed how it gets oil out of the lower end with that scraper, any change there causes oil to back up in there, and they in 79, I believe, they might have done it in 77, but in 79 for sure, they ran the breather hose to the air cleaner. So your air cleaner would start dripping oil and stuff back then. And then I'll tell you another thing that they laughed at the factory was people putting filters on the breather line off the engine, which further restricts this. Totally stupid. And then they come up with crap like, well, if you don't put a filter on it, I've seen rocks in the breather. You get rocks and gravel if you're right on a gravel road. Sand and stuff gets in there. Absolute nonsense. I've done hundreds of shovel head engines. Matter of fact, I kept a log, and in 13 years at location on Pine Street I had here, I built something like 547 shovel head engines. So I know my way around shovel heads. But anyway, so we'll get back to connecting rods. So what happens on that exhaust stroke, without that cushion of compression, it's throwing that rod up, then suddenly reversing it, and it's causing the rod to stretch out of the bottom, all right? So even new rods made out of 4140, S&S rods and all that are going to go egg-shaped a little bit, less so than the malleable cast iron rods. But one of the things that I found interesting at the factory, and one of the things I found interesting about owning a brand new 1977 Sportster, was that it lasted 15,000 miles before it started burning oil. And that's very typical. And the big twins were quite a bit better. You could probably get about 35,000 miles out of them before they needed the top end rebuild. People would find that totally unacceptable today, but we lived with it back then. And back then we could work on our own motorcycles. You buy a new one today, you might as well marry the dealer, because you can't fix the electronics, you can't change nothing. You have to buy a power commander, then you're stabbing in the dark. What it really requires is especially with fuel injection, about 206, I think everything went fuel injection on them. You got to have a dyno to tune them. And I just go, man, this is crap. And the economy took a dump, and I went back into hydraulics where I can make some money and less grief. I'm going to come back in a minute, and I'm going to find me a cup of coffee. Well, back here with a cup of tea instead of coffee. It's pretty late. And I'll tell you, I'm kind of tired. I hope I'm making some sense. Well, the Sportster that I bought in '77, it ran 15,000 miles before it started smoking, and I went and traded it into the dealer there, and I got a 1978 and a half 80-inch big twin Electroglide. That's when they come up with their 80-inch. They were 74 before that. And it was an okay bike, but they took the lead out of gasoline in 1979, and that started raising havoc. In the cylinder heads up into 1980, 81, there was just a lot of engine failures and a lot of problems, like I said, with that 1979. And new motorcycles were like leaking on the floor, brand new, and it was kind of hard to sell those things back then. Things went kind of slow. The cylinder heads, the valves and the guides, they used a soft valve and a hard guide. They called the guides Carpenter steel, which is a patented steel. The valve guides are Carpenter steel. Then to help with the unleaded gas, I think it started in 1980 and had it perfected by the end of 81, adding valve stem seals to the new cast iron guides. And they went with a black oxide coated valve, nitrided valve that was harder. So they used a softer guide with a harder valve, and that solved that for the Shovelheads. And of course, when they went with the Evos, they used that same formula. Well, when I went to the factory there, I mentioned to the Sportster Machine Shop guy, we had a Sportster one, we had the big twin one. There was a little separation there, a little bit of rivalry. I says, man, I got this new bike, 77, and, it lasted 15,000 miles, in '77 was a big change on the engines. They put a sump on the bottom to help catch the oil, and then they went with a gear rotor oil pump. That's like a gear within a gear on 1977. The gear rotor oil pump and the sump. Well, what the guys at the factory did, and they could do easily, is they'd run those things. You run the bike for that 15,000 miles till it started smoking, and then you broke the thing down, and then you honed the rods and fitted with oversized bearings, taking care of that egg shape. Because after the initial stretch from that end of the exhaust stroke, where there's no cushion of compression, and it just throws that piston and rod up, and then all of a sudden pulls it back down, and it stretches the rods out at the bottom. So if you rebuild the rods at that point, there's a better chance that it's going to stay round. And they were just getting into torque plating cylinders back then, and they were doing it at the factory, and that's when I started torque plating all cylinders, was way back then, which dramatically increased the life of a cylinder. I believe I talked about that, how that thin sleeve that some people want to grab in a chuck would flare out. And see, the machinist experience, that you can't grab something thin like that and turn something heavy and without ramifications. So and this is another thing, if you look in the older manuals, and they'll say, if the cylinder's not scored, gouged, or in terrible shape, you don't need to use a boring bar, which can be problematic in many ways too. You use the sun and hone. So if you're going to go from stock to 10 over, you put these really coarse stones in there like I got, and you run them dry, and you would not believe how fast that 10,000ths will come out, and you can resize the cylinder with a hand drill and the sun and hone tool. These are quite expensive. There's some expensive stuff you have to have. One of them is that line lapping tool. It's critical if you want to get a long-lasting engine. And another thing, you can't build a $1,200 engine without using the cheapest crap on the market. And if you use like S&S and Jim's parts, and the best stuff you can buy, you're over $1,200 in parts. So it's going to, back then, I did engines for around $2,500 or a little bit more. I wanted $1,000 per engine, and I worked my ass off for that $1,000 because I wanted stuff to run right and work right. Like I say, if it doesn't in this state, they sue you. So that was part of the thing that I did too. And I'm going to tell you another thing that's critical. And this is how you get a bulletproof lower end. Yeah, let me grab that. So you got all these bearings. You got the main bearings, and you got the rod roller bearings, all coming in oversize. This thing here is out of Sikorsky, and they use roller bearings in helicopters. And this is a bearing checker. It's a standard Poughkeepsie bearing checker. You see that? It reads in tenths. So this was recommended at the factory. Every single bearing that goes in the engine, you got to check every one of them. And then you decide what the tolerance would be. And my standard was 0.5 tenth, 50 millionths if I showed half a mark. So you get these bearings in packages of 100, and I'd go through those bearings, and then I would separate them. You know, I would group them, find some that are a little bit under, some that are a little bit more. And then what happens if you don't check them is there could be one that's a couple of tenths oversized in there, and you wouldn't know it, and that's going to dig in, and it's going to wreck your rods, or it's going to cause problems on the main shaft. So if you could use something like this, or a 10th indicator on a granite surface plate. That's what I did at first until I got that, and checked the bearings that way. And then you won't have mystery rod failure. I thought you might enjoy that. Mystery rod failure. And what that means is when it goes bad, it looks like hamburger. So what went wrong? Who knows? It could have been an oversized roller. But I'll tell you what, I never had a lower end failure whatsoever once I started checking every single bearing. And I can go back into history. You might find this interesting. If you get your hands on a very early manual, you could build a whole Harley Davidson engine without micrometers. And a lot of mechanics didn't know how to use micrometers very well. So they used feeler gauges on the pistons. And on the rods, once you lapped them out with the lapping tool, that's similar to the main bearing tool, but it's shorter. I think I've shown that. Is you plug fit them, is what it's called. So you start testing with these bearings until you get the crank pin so it's tight, but it still goes through. Then you subtract the clearance, which might be 1/1000th of an inch, and use bearings that are undersized, like they come in that steps of 2/10. You calculate the undersize you need to get the clearance after the plug fit. And you fit the main shafts that way and the crank pins and the rods. So I don't know if I can demonstrate that. I'd like to. That's an old way of doing things. So what they did, and they call a set of rods that have been run that you can relap or hone or both. I did both. I used the sun and hone to clean up the rods, and then I ran the rod lap through it to get the work hardened and proper finish on the rod bearings in particular. And you want they specified a crosshatch with that lapping tool, so you like a cylinder. And the reason for that is it would retain oil better, and it would get those rollers initially rolling. And one of the things that they advised against is using grease to retain any of the bearings, because that could cause a bearing to skate. And then if that happens, it'll get a flat spot on it. Then eventually you're going to have a mystery rod failure. Does that make sense? I hope so. So they would take these Sportsters, the guys at the factory, and like I mentioned before, they rode them in the winter. They put a sidecar on them. And they would run them until they smoked, and they'd go through it, torque plate the cylinders, redo the rods, just go through everything. And then you get a Sportster that might run 25,000 miles. So all that was solved with the Evo Sportster, which turned out to be a very, very good engine anyway. So you get what you pay for, and there's no substitute for quality. There just isn't. There's no benefit of going cheap. Going cheap is expensive if you really think about it, depending on what you want to do. The people I built engines for rode them, and I built up a reputation of putting out really very good engines. The dealers were very happy with me, and so were the customers, individual customers I had. So I'm rambling on a lot here, but I just thought you might find that interesting, some of those things. And I'll keep coming up with stuff like that might be helpful for you from the millwright's perspective. And it was quite an advantage for me to have the machine shop experience, and it'll go a long ways for anybody that wants to tackle these engines. And these engines are like a puzzle, and they're kind of interesting. And you'll find that, and everybody knows it, well, that engine really runs good, and I don't know about that one really vibrates and stuff like that. That's from the sloppiness of the things being kicked out at the factory, really sloppy work. And you take something like a Honda Goldwing. I've never done a cylinder head for a Honda Goldwing. I've never seen a cylinder head off a Honda Goldwing. I've seen a lot of people come into the shop at the dealership where they pulled the cylinder off the bike and got a car ride to the shop to get it to get a head and the cylinder fixed, but never on a Honda Goldwing. And the one thing about Hondas was the maximum inaccuracy was around 2 thousandths of an inch, and they had a consistent running, and like the pistons coming up to the cylinders, to the top and stuff like that. 2 thousandths of an inch. On Harleys, it could be up to 15 thousandths error. Then there's all that core shift and stuff like that with the heads. Those shovel heads were terrible. The best thing that ever happened to shovel heads is S&S made replacement heads. Those worked out very, very good, and I always recommended them to people. Well, okay, let's get over and look at this K model, and I'll show you what I run into. I got a problem. Okay, here we are. So I took this end mill here and circle ground it, rotated it and ran the wheel on the tool and cutter grinder while I was spinning it in the Rotodex. And it made the flutes so they don't cut, only the end cuts. And what happened, I had never seen it on these engines, is on the right case they staked the dowel pin in. I don't know if there's still one hanging around here. They staked it in and had a little steel sleeve, and I couldn't get the sleeve out, so I thought, well, I could just run the end mill in there and cut the sleeve and make the hole at the same time. Well, that didn't work out too good. I got a little bit out of around holes here. So I'm going to have to put a boring head in here and go and dust out these 3 holes here. So that's a whole nother operation that I have to do. Well, it's not that big a deal. I'll just set up a boring head and do that. I'll try to video that. So I will be back doing that probably tomorrow or maybe the next day or so. I'm not sure what I'm going to be doing. And I'll just give you something to chew on, some of the stuff I talked about. And I have a whole lot more to talk about too, with little things about these motors. But I wanted to point out to you, there is no easy way out on these. There's not. You can't build an engine for $1,200. That's going to last. It's not possible. You can't use good parts because the parts cost $1,200. And I'll discuss some of the other stuff I used in piston selections and things like that. Okay, have a good day, a good night, and I will be back. Thanks for tuning in.